We are now going to put it all together. So everything that we have learned thus far in this question, we're going to see it all together. You might like to try this question for yourself before you see me go through it. So we're going to launch into the question now. It says, the hours of sleep and number of REM, rapid eye movement occurrences, of 10 adults were recorded. The results are shown below. So here we have hours of sleep. Here we have REM occurrences. Part A. In this investigation, which would be the response variable and which would be the explanatory variable? Remember, when you're asking the question of which is the response and which is the explanatory variable, you're asking the question of what is impacting or affecting the other one. So in this case, the hours of sleep is going to impact or affect your REM occurrences. So what that means is that my hours of sleep is my explanatory variable and my REM occurrences is my response variable. So we're going to write that my explanatory variable is going to be hours of sleep and my response variable is going to be the REM occurrences. Perfect. So there we have identified my explanatory and response variables. Okay, now we move on to the next part in which we are going to construct a scatter plot. Now, we could use our CAS to do this, but the numbers are such a way that it's actually quite easy just to look at our graph and to write them straight. So let's give it a go. The first thing you're going to make sure that you do is label your axes. So my explanatory variable is my x-axis and it is the hours of sleep. So I'm going to begin by coming here and writing hours of sleep. And then my response variable was REM occurrences. So we're going to come over here, REM occurrences. Then once we've done that, we need to scale our axes here. Let's have a look and just see if we can figure it out. We've got 1, 1.5, 2, 2.5, and all the way up to 5.5. So what I'm going to do here is I'm going to skip every second one and go 1, 2, 3, 4, 5. And then over here, if I look up here, I'm going from 10, 20, my highest one is 35. So I'm going to go up by 10s, again, skipping one each time. So 10, 20, 30, 40, 50 there. Perfect. Having now done all of that, we're just going to plot the points. So let me grab another color here to spice things up. And I'll come here and I'm going to go, all right, 1 and 10. 1 and 10 will be there. 1.5 and 20. 1.5 and 20 will be there. 2 and 15. 2 and 15 will be there. And we're just going to continue on until we have it all done. 3 and 20. 3.5 and 20. Then I've got 4 and 25. 4 and 25. 4.5 and 35. Then I've got 5 and 30. And then I've got 5.5 and 35. So just make sure that you don't make any silly mistakes here. It's not tricky stuff, but it is easy just to put something in the wrong spot. And just make sure those look good. Perfect. So we have all of that sorted right there. The next thing that we have to do is use the scatter plot and comment on the relationship between hours of sleep and REM occurrences in terms of direction, strength, form, and outliers. Now here is one I prepared earlier. The association between hours of sleep and REM occurrences is strong, positive, and linear, with no obvious outliers. So take note of the fact that I have addressed each of these things. Direction is positive, strength is strong, form is linear, outliers, no obvious outliers. So just make sure that you're addressing everything that the question says. Make sure to pause if you need to write things down, but I'm going to continue going on. Okay, next, calculate the Pearson correlation coefficient of R. Okay, so how are we going to do that? Ooh, my computer is about to die. Let me quickly plug it in. Ready, set. It is now plugged in. All right, we're back, people. Okay, so calculate the value of Pearson's correlation coefficient in terms, correlation coefficient R, correct to 2 decimal places. This is where we're going to use our CAS calculator. So we're going to come over here. And as you can see, I've already put in the relevant information. So I've got hours here. I've got REM here. To figure out what my R value is going to be, I'm going to go menu. I'm going to go statistics. I'm going to go stat calculations. I'm going to go linear regression. Then I'm going to go hours because that's my explanatory and REM for my Y. then I'll hit OK. And then we're going to scroll down until we get to R. And there is my R right there. So I'm going to come here and write down what that is. So my R is 0.82686. Now, it says that I need to do this correct to 2 decimal places. So that means R is going to be 0.83 because that 6 is going to round that 2 up to a 3. So just make sure that you don't make any silly mistakes rounding. Okay, let's continue on now. It also says that I need to interpret the value. That's when you would refer to this little table here. And as you can see, it's going to tell us whether or not we're strong, weak, negative, or positive, or moderate. So because I'm 0.8, that puts me here between 0.75 and 1. So that means it's strong. It's also positive. So it's a strong positive relationship. So I'll come over here and I'm going to say that it is strong and positive. We continue moving on. Next, it says calculate the value of the coefficient of determination r squared to 2 decimal places and interpret that. So this is where we're going to come back to our trusty CAS calculator, and we're now going to look at our r squared value, which is 0.68371. So let's come here and we're going to write r squared is 0.68371. Again, it's asking us to round it to 2 decimal places. So we have to be careful here. R squared is going to be 0.68 because that 3 doesn't round anything up. So there is our answer right there. So just make sure it's clear what your answers are. And again, make sure you're reading the full question because it's also asking us to interpret the value. Here is an explanation that I wrote previously. It says the coefficient of determination tells us that 68% of the variation in REM occurrences is explained by the variation in hours of sleep. So remember, 0.68 is the same as 68%. And when you're writing your explanation, you want to say it as a percentage. So that is going to be your answer there. Make sure you pause the video and you're writing down everything that you need to, but I'm going to continue on so this video doesn't get too long. Okay, next, calculate the least square regression line and state in terms of the variables. Okay, so remember our least square regression line is going to be in the form of y is equal to a plus bx. But the fact that it says in terms of the variables means that we don't want to include y and we don't want to include x. We want to include the variables that they've given us in the question. So that was hours of sleep and REM occurrences. So what I'm going to go and write now is, let me just quickly move this. I'm going to write REM occurrences because that's my response variable is equal to, now I need my a value, and that's no worries because I can just come and look over here and you can see that a is 9.03. So I'm going to come here and go 9.03 plus what is my b value? It's 4.6 and I'll round that up to 1. So it'll be 4.61 and that's going to be times by my explanatory variable, which is going to be the hours of sleep. Hours of sleep. And there it is. There is our least squares regression line. Perfect. All right, we are continuing to soldier on here. Next is asking us to interpret the slope and y-intercept of the least square regression line. So first, slope. And again, here's one I've prepared earlier. You might like to try to write one before I show it here. So again, I'm just using the template that we have given you. So no surprises here. We're just filling in the gaps in the template. So on average, the number of REM occurrences increases by 9.03 occurrences for every extra hour of sleep. Can I draw your attention to this very important units being listed here? Looking at past exams, this is often where people make a mistake. You have to specify the units of your explanatory variable which are going up. So with every extra hour of sleep. So just make sure that you're careful when writing that. The next thing we have to comment on is the y-intercept. Let's have a look of what an ideal answer here would be. So again, we're following that template that we have provided you. On average, when the hours of sleep had is 0, the number of REM occurrences experienced is 9.03. Now, this is invalid, as you must be asleep to experience REM. So this is one of the occurrences in which the y-intercept doesn't make any sense, because remember the y-intercept occurs when x is equal to 0, and in this case x is the hours of sleep. So it's saying if you are asleep for 0 hours, so in other words you're awake, how much REM occurrences are going to occur? Well, you can't have any REM occurrences because you can't be awake and experience REM. So this is an instance in which the y-intercept is invalid. Let's keep on moving. Here it says, use the regression equation to predict the number of REM occurrences for a person who has slept for 1.75 hours and 8 hours, and then also comment on the answers. Okay, so what we're going to do here is we're going to take our regression equation. So REM is equal to 9.03 plus 4.61 times. And now this is where we're going to substitute in what they've given us, 1.75. You would then get your CAS calculator and put this into your CAS. And when you do that, the answer that you're going to get out is 17.0975. And again, if you wanted to see how to do that on the CAS, let me quickly show you. So let's come over to the CAS, and I'm sure you can all do this, but let's do it anyway. Control, Doc, add calculator, and then we're just going to type that in. So 9.03 plus 4.61, and then we're going to times that by 1.75. We hit enter, and there is our answer right there, 17.1075. And whoopsie daisy, I've accidentally written it a little wrong. Let me just double check I've typed that in correctly. 9.0. Oh, sorry, I wrote that in wrong. That should be a 3. 9.03 plus 4.61. I did do it correctly before. There it is, 17.0975. Now, it also wants me to comment on the reliability of the answer. Well, if it's 1.75 and I come up and I look at the little scatter plot I made before, it's clearly 1.75 would be about here, and I'm within the data range. So that means this is reliable because it's interpolation. So let's come down here, and I'm going to write reliable as interpolated. Perfect. We now move on to the next one here, in which is dealing with 8 hours. So we've got REM is equal to 9.03 plus 4.61. And this time we're going to times it by 8 because that is what they've given us here. So just as over here, they gave us 1.75, now they're giving us 8. And to put this in our calculator, to save ourselves some time of typing it out again, go up, go down. So I brought that down. I'm going to get rid of 1.75. I'm going to put 8 in there. I'm going to hit enter, and I'm going to get 45.91. So that means it's going to be equal to 45.91. Now, again, it's asking us to determine whether or not this is reliable. Well, I'm dealing with 8. Well, if I come and look at my scatter plot again, do you see that I stop at 5? 8 is not within the data range. So that means we're doing extrapolation here, which is unreliable. So this is going to be unreliable. And we're going to say as extrapolated. Perfect. We are going to continue on. You might like to pause the video and just make sure that you're getting everything that you need. Okay, next, we need to construct a residual plot and use it to comment on the appropriateness of assuming that hours of sleep and REM occurrences are linearly related. So here we need to make a residual plot. How can we do that on our CAS calculator? So we're going to come over here, and if you wanted to, you could simply come here and get all of your residual values there. So you could take all of these and use that to create your graph. Another way for you to do it is to go Control, add Doc, add data and statistics, and then here we're going to go hours. Here we're going to go REM. And there is our graph. We're then going to go menu. We're going to go analyze. We're going to go regression and then show linear, A plus B X. And there is our regression line. Then once we've done that, we can go menu, analyze, and then residuals, and then show residual plot. And here it is right there. So this is what we're going to sketch. So if we come here for a moment, we begin by labeling some things. We need to label that this is the residual value, and make sure you write it nicely. This is the residual value. And remember, your x-axis doesn't change. So your x-axis is what the original one was, which is still hours of sleep. And I'm going to keep the same scale. So I'm going to go 1, 2, 3, 4, 5. For my residual, remember, I'm going to go here And I'm going to put a dotted line. That's where 0 is going to be. And then what I'm going to do is I'm going to go up 2, 4, 6, 8, and I'm going to go down -2, -4, -6, -8. Now I know to make that scale because I've already looked at my data points here and I've kind of just made it in that sense. So I know that the highest I'm going to go up to is 9.45 and the lowest I'm going to go down to is -5.15. So that just ensures that I've got it all there. Now, as I said, you could just hover over each one to get the value. So the first one is 1, -3.64. So that means I would come here and I'd go 1, -3.64 would be about here. And you would keep on going. So then I would go to the next one and I would say, next I'm 1.5 and 4.06. So 1.5, 4.06 would be about there. And then you could continue on listing them out. Also remember, if you didn't want to do that, you could come over here. And as you can see, the first one is -3.63, then 4.06. This is also giving you those residual values. Just so you don't have to watch me mindlessly put all those numbers in, here is one that I've prepared earlier. So you can have a look. And this is just going to save us some time. So you don't have to watch me writing. Although, if you like to watch me write, I don't know why you would. Okay, there it is. There is our residual plot right there. The next thing we need to do is we need to comment on our residual plot. And here is one I prepared earlier. Let's give it a read. So the residual plot has, now this is the important bit, no pattern and reasonably even split of positive and negative values. This confirms that the relationship between the two variables takes a linear form. Now, we've looked at past exam questions and the answers that they expect. You must identify that there is no pattern if you have a linear association. If you just say that there's an even split between positive and negative values, you won't get the mark, because what really determines it is the no pattern. This also is true for linear relationships, but this, the no pattern, is the big one as well. Okay, and now we come to the lucky last one. I apologize for the very long video. Whoa, I've been talking for 17 minutes. That's amazing. All right, from your analysis, can it be said that an increase in the number of hours will cause an increase in the number of REM occurrences? See this word cause? They're trying to trick you. This is what an answer should say. So a good answer would say something along the lines of, the relationship between hours of sleep and REM occurrences is strong, and one is a good predictor of the other. However, correlation does not mean causation, and we can never say that changing one will cause the other to change. So they're trying to catch you out there, but you know that correlation does not mean causation. So just make sure that you include that in your response, and you should be aiming for something that looks like that. Okay, everyone, I again apologize for the extra long video, but hopefully you feel comfortable with all the skills that we've gone through in putting this all together. I will see you later.